Hello everyone. In this video, I'll try to explain about ambiguity in grammar or ambiguous grammar. Uh, First of all, uh, let us see the definition of ambiguous grammar, and after that, we will take an example from our class notes where there is a grammar and a string that can be generated by that grammar, and we eventually prove that the grammar is ambiguous by drawing parse trees. So let's now go through the definition. Here is the definition of ambiguous grammar. For some CFGs, it is possible to find a terminal string with at least two different parse trees or equivalently two different derivations. Such grammars are known as ambiguous grammars. Simply, uh, if there exists more than one parse tree or equivalently more than one derivation for an input string, then that grammar is said to be ambiguous. So now let's take an example. This example is already there in our class notes. I'll try to explain that. So the example is there's a grammar G where P gives two P's, P gives bracketed P, and P gives epsilon. And we have a string W. So this is a string W. So this string W can be generated in two ways by using this grammar G. I'll give that parse trees. I'll make that parse trees, and then I'll prove this grammar as ambiguous grammar. Because if we have two different parse trees for a single string in the grammar, that grammar is said to be ambiguous grammar. So let's now get started. First of all, let us name these productions. Let us name these productions as let this be production number 1, let this be production number 2, and let this be production number 3. So we are trying to build our parse tree number 1. So while constructing, while making out parse trees, we have to start with the start symbol. Here in this grammar, the start symbol is P itself. So let us start with P. Using the production rule 1, P can give two P's. Or let me change these colors so you will be able to know which production I used. Let us change this to, so this is one green color. I'll change this to something yellow, production number 2, and I'll change this to red. So I used green here so that I used production rule number 1. P gives two P's, and let's progress here. The next is sorry. mm, P again gives 2p's, right? P can again give 2p's. Production rule number 1. And then this P can give open bracket P and closed bracket, right? Production number 2. And this P can give open bracket P and closed bracket. In the string, we now generated up till here an open bracket and closed bracket using this P. Now we need 3 opening brackets and 3 closing brackets. So with this P, I am trying to do that. So using production rule number 2 multiple times for this P also. Let's say open bracket P and close bracket, open bracket P and close bracket. Yes, now I got this, that 3 opening brackets and 3 closing brackets. Now I need to end it here, so I need to use this production rule 3. P gives epsilon, so this P gives epsilon. P gives epsilon and this P also gives epsilon. Production rule number 3. And what all we have left is 2 open brackets and 2 closed brackets. With this P, we will generate 2 open brackets and 2 closed brackets. Now we passed up till here, and we have this part to be passed. Now let's use production number 2 here. Open bracket P and close bracket, open bracket P and close bracket, and this P is epsilon. So this is production rule 3. These are production rule 2, and these green ones are production rule 1. So this is the pass tree number 1. We have just now generated the string, our string W, as you can see. So there's another way to generate this string for this grammar. So let's now do that. Pass tree number 2. So pass tree number 2. What we have done in pass tree number 1 is we generated 2 p's, and in the left side we generated 2 p's again. So now we'll do the to the right side. We will generate 2 p's here. Let's see what happens. So we have P here, and using the production rule 1, we can generate 2 p's like this, and this P will use production number 2, I guess. Yeah, production number 2, and generate open bracket P and close bracket. Now I think we are done with this side. Yeah. And using production number 1 here again, here P use 2 p's, and this P we can use we now need 3 open brackets and 3 closed brackets, right? So we can generate that. We can generate that using production number 2. Open bracket P and close bracket, open bracket P and close bracket, open bracket P and close bracket. So here we need 2 open brackets and 2 close brackets, right? Open bracket P and close bracket, open bracket P and close bracket. So now we have to use the third production rule, which is epsilon. So this is the parse tree number 2. We have now generated the same string W using this grammar G. So as you can see, we have the same string W again with this parse tree. So this type of grammars are called ambiguous grammars. I hope I explained you and you understood. Thank you.